Now, to draw the shear force diagram, here VB, VA, VB, VC, VD are the support reactions. Here we have to consider the equilibrium of, if we consider the span only this span AB span, here by considering summation of MB equals 0. Here remaining part we have to not consider, only the left portion. Here this portion we have to close this. Here it is like this. Here in this portion here only this portion we have to consider, that is only LHS. In this LHS, that is VA into, by taking moments of all the forces about B equals 0, VA into 4, that is clockwise, that is positive. Then here there is a support moment, that one is anti-clockwise, that is minus 53.90 kilonewton meter, and this one is subjected to UDL of 50 kilonewton meter. Then the total load is 50 into 4, that is the total load, which is acting at a distance of 2 meter from either end. Now we are calculating the moments about B. Then the perpendicular distance is 2 meter. Then the moment is in anti-clockwise direction. Then plus here there is a support moment, that is 92.2, that is in clockwise direction. This one equals 0. The sum of all these equals 0. Therefore VA equals or RA equals 90 point, by simplifying you will get 90.425 kilonewton. This one is positive, that means that is upward. Here the direction is upward. Then similarly in the same way we can close this portion in portion CD, that is summation of MC equals 0. Only we have to consider the right hand side of C, that is here it is subjected to 80 kilonewton point load at the center. The two support moments, one is 56.39 and one is 46.80 kilonewton. Then by taking moments of all the forces about C, that is VD into distance is 5 meter, that one is anti-clockwise. Then 46.8, that is clockwise, 80 into 2.5 about C, that one is also clockwise. Then the support moment, that is 56.39, that one is anti-clockwise. The sum of all these things equals 0. Therefore VD is the only unknown. VD equals, that is here we will get 38.08 kilonewton, that is also positive, hence that is upward. What we have assumed, that is upward. Then summation of MB equals 0. Again now we have got remaining two unknowns that we have to calculate by taking either summation of MB equals 0 or summation of MC equals 0. Now in the previous case we have considered LHS. Now we will consider the RHS of B. That one is here, this one is B. We have to close this portion, that is summation of MB equals 0, that is we have to consider RHS, right hand side of the B. Then start from one end, that is VD is already we have calculated, that is VD into distance is 5 plus 6, that is 5 plus 6, that moment is anti-clockwise, then this moment, that is 46.8, that is clockwise, 46.8, that is clockwise. Then moment to this point load, that is 80, and the distance is 6 plus 2.5, that one is clockwise. Then these two moments, one is positive, one is negative, both are the summation of these two are 0. Then VC into distance is 6, the direction of the moment is anti-clockwise. Then 120 into distance is 2 meter, the direction of the moment is that is clockwise. Then here the support moment, that is 92.2, that one is 92.2, that one is in anti-clockwise direction, this equals 0. Therefore here Vc is the only unknown thing. Vc equals 75.95 kilonewton. That is 75.95 kilonewton. That is also positive. That means that is upward. Then by one of the equilibrium equation, summation of Fy equals 0, that gives us Va plus Vb plus Vc plus Vd, all are we have assumed in upward direction, minus the downward forces, that is 50 into 4, that one is downward, that is due to UDL, minus 120, that is pointward, minus 80, that is downward. Here the summation of all these things equals 0. Therefore here we have calculated Va, Vd, Vc. Then Vb equals, that is at B the reaction is 195.545 kilonewton. This one is also positive, that means that is also upward. Now we have calculated all the support reactions. Then to draw the shear force diagram, start from one end. This is Va, Vb, Vc, Vd, Va, Vb, Vc, Vd. Here start from one end. As per your sign convention, left upward is positive. Here left upward is positive. Here if you consider a section in between A and B, at A the shear force is, here I will draw a reference line or datum line. Here Va is, just now we have calculated, that is 90.425, 90.425, that is upward. Only to the left side there is only one reaction. Then here there is a UDL, that is 50 into 2, that one is 50 into 4, that one is 290.425 minus 200, that one is, here that the variation is a straight line, the shear force variation is a straight line, and the ordinate of that one is 92, 200 minus 90.425, that one equals, that is 109.58 kilonewton. Then similarly here this is minus 109.58. Here there is a support reaction Vb, that one is 195, that one is 92 point, that is 85.96, 85.96, that one is 109.58 plus the support reaction, that is upward, that one is 54, that one equals 85.96 kilonewton. Then here from B2 up to point load, here there is a point load, here this is UDL, here UDL the variation is a straight variation is, it decreases gradually like this. Here from this point to this point, this one is constant. Here this one is 85.96, this one is minus 120. Then this becomes, here this one is 85.96 minus 120, that one is 34.04 34.04 kilonewton. Again here in between this point to this point there are no loads, this one is 34.04. Here there is a support reaction Vc, that is upward, that is minus 34.04 0.04 plus 120, you will get 41.91 minus 34.04 plus, that is support reaction 75.95. Here you will get 41.91 kilonewton. Then here up to this, from this point to this point, there is no load. Here there is a load of 80 kilonewton. Here this is positive. Then again 41.91 minus 80, that one is 41.91 minus 80. The shear force ordinate below this point load in span CD, that is 41.91 minus 80, then that one is minus 38.08. Then here there is no load in between 80 kilonewton and this support, then this remains constant. At support there is a support reaction VD, that is 38.08 minus 38.08 plus 38.08, that becomes 0. Here the variation of the shear force is, here this one is upward, and then because of this UDL the shear force decreases gradually and it is a straight line. Then here there is a support reaction VB. Due to this the shear force it changes from minus 109.58 to 85.96. Then here it remains constant from B to this point load, then that is positive 85.95 minus 120, this one is downward, then that becomes minus 34.04, then that remains constant up to C, that is negative. Then here there is a support reaction VC, that is 75.95 minus 34.04 plus 75.95, that becomes 41.9, that one is positive. Then it remains constant. Here I have shown the arrow mark. Then because of this point load, that is 41.95 minus 91 minus ET, that is 38.08. Again there is a support reaction, that becomes 0. Here the variation of the shear force I have shown by the arrow mark like this. This one is regarding the shear force. If you want to draw the elastic curve for this, that is here by observing the bending moment diagram. Here by observing the bending moment diagram for this beam, here this one is the elastic curve. Here this one is hugging moment at the support. Then here the deformed shape of the beam, it will undergo deformation due to external load. Here this one is hogging at the center, that is sagging, again at support, that is hogging, at center, that is hogging, sagging, then at support hogging, and the slope at this end supports, both the ends are fixed, the slope is 0. Here the bending moment changes from negative to positive. Then these are the point of contraflexure. Below this, here these are the point of contraflexure. I have shown with the dotted line for each and every span, that you have to calculate these position of the point of contraflexure. Here this one is, this completes with this problem. You have to draw the elastic curve, bending moment diagram, shear force diagram in your examination. Okay, thank you. We will continue in the next video.